You're standing on Earth right now, and the Earth is spinning at about 1,600 kilometers per hour. So here's the question. Why aren't you flying off into space? I mean, if you spin a ball fast enough, things fly off it. Wet clothes fly off a spinning washing machine. Mud flies off a spinning tire. So why not you? Something doesn't quite add up. Let's start with something simple. Imagine you're sitting in a car. The car starts moving, slowly at first, then faster, then really fast. Do you feel like you're being thrown backward the whole time? No, you only feel something when the car speeds up, or slows down, or turns. But once it's moving at a steady speed, it feels normal. That's the first clue. Now, Earth is spinning. Fast, yes, but it's spinning steadily. It's not suddenly speeding up or jerking around. So you don't feel that motion the way you might expect. But still, something should be pulling you outward, right? Let's make it more dramatic. Imagine you're on a giant spinning playground ride, the kind where you hold onto the bars as it spins faster and faster. You feel yourself being pushed outward. You have to grip tightly or you'll slide off. That outward push has a name. It's what we call the centrifugal effect. So, why doesn't that happen on Earth? Well, it does, just not the way you think. Earth's rotation does create a slight outward effect. It's trying, very gently, to fling you into space. But here's the key idea. Gravity is stronger, much stronger. Think of it like a tug of war. On one side, you have Earth's spin, pulling you outward. On the other side, you have gravity, pulling you inward, toward the center of the Earth. And gravity is winning, easily. In fact, gravity is about 300 times stronger than that outward spinning effect at the equator. So even though the Earth is spinning incredibly fast, gravity holds you down with a firm grip. You don't even notice the competition. But here's where it gets interesting. You actually weigh slightly less because of Earth's spin. Not by much, but if you were standing at the equator, the fastest moving part of Earth, you'd be just a tiny bit lighter than if you were standing near the poles. Because at the equator, the spin is helping, just a little, to lift you up. Strange, right? Now let's push your intuition a bit further. What if Earth spun faster? Much faster. At some point, the outward effect would get stronger and stronger until it matched gravity. At that exact speed, something wild would happen. You would become weightless, not because gravity disappeared, but because the spin perfectly cancels it out. And if Earth spun even faster than that, then yes, you really would fly off. But Earth is nowhere near that speed. So for now, you're safe. But here's the twist that really changes how you think about all of this. You are already moving incredibly fast. Right now, sitting still, you are moving thousands of kilometers per hour because of Earth's rotation. And on top of that, Earth itself is orbiting the Sun at about 100,000 kilometers per hour. And the Sun, it's moving through the galaxy even faster. So why don't you feel any of that? Because motion itself isn't something you feel. Only changes in motion are. Speed doesn't matter. Acceleration does. That's a deep idea. If everything around you is moving together, at the same speed, in the same direction, it feels exactly like being at rest. There is no experiment you can do inside a smoothly moving system to tell whether you're moving or not. It's like being inside a perfectly smooth airplane with no windows. If it flies straight at constant speed, you'd have no clue you're in motion. Earth is like that, just much bigger. But let's take this one step deeper. Why does gravity win this tug of war in the first place? What is gravity really? Here's a way to think about it. Imagine space itself is like a stretched rubber sheet. When you place something massive, like Earth on it, the sheet bends, it curves, and everything nearby, including you, naturally slides toward that curve. So gravity isn't really a force pulling you down in the usual sense. It's more like you're following the shape of space, and Earth's rotation is trying to nudge you sideways, just a little. But the curve of space is so strong that you stay stuck to the surface. Now picture this. If you jumped straight up, for a brief moment, you're not touching the ground. So why don't you land somewhere else? After all, Earth is spinning underneath you. Shouldn't the ground move away? But it doesn't. You land almost exactly where you jumped. Why? Because you were already moving with Earth before you jumped. You, the ground, the air, everything shares that motion. It's like tossing a ball straight up inside a moving train. The ball doesn't fly backward. It comes right back to your hand because it already has the train's motion. Same with you and Earth. You are not separate from its motion. You are part of it. And that's the deeper insight. We often think of motion as something obvious, something you should feel, but the universe doesn't work that way. There is no absolute still. Everything is moving, all the time, relative to something else. And yet, from your point of view, standing here on Earth, it feels perfectly still. So why don't you fly off a spinning Earth? Because gravity holds you tighter than the spin can throw you. Because you are already moving with the Earth, not against it. And because motion, by itself, is invisible to your senses. Only change reveals it. And maybe the strangest part of all is that right now, as you sit there, completely still, you are part of a cosmic dance at unimaginable speed, yet you feel nothing at all.